Hello, my name is Michael Byers from the Outer Space Institute, and you're about to watch a discussion that I had with Dr. Jan Wörner, the Director General of the European Space Agency, in October 2020. And the interview begins with Dr. Wörner responding to a question that I asked him concerning the origins of his interest in space.
My father took me on his arm and said, "Look, Jan, there is a tiny Sputnik." I did not see anything, but if your father tells you when you're 3 years old, there is something, then you see it. So this was the starting point. And from that point on, I followed all the space missions of East and West, whatever I could get. I have a big collection from that time in my home. But I never thought about that I would be part of this space issue. And then I started civil engineering. And at the end of the civil engineering, I had to write 2 theses. And these were not about earthquake, but it was about aircraft impact on nuclear power plants. So very special topic. And then I went into a small engineering office, and there they said, okay, this is a guy who knows about aircraft impact. Maybe he also knows about earthquake engineering. So I just threw me into earthquake engineering, and then I got a big project. And as part of that project, I traveled to Japan for a little bit more than 1 year to investigate what we can do for the safety of nuclear power plants during the case of earthquake. And this then is following up. So I think I'm far away from normal space activities, but I believe if you are through an engineering study, or if you are through a whole study at all, then you have a different mindset than without the study. So whether it's engineering or other fields, this is not the case, but you have a different way of thinking, because during all the studies, whatever you take, you get some task to deliver in time. And this changes your mind. And as an engineer, you're always looking to solutions for a problem. You're not looking for problems, you are looking for solutions. And I think this really changed in men or women as well. And therefore, when I then got stepwise closer to space, I was very happy that I finally got the position of a Director General of the European Space Agency, which is more than just engineering, because it's also political.
Yes, and in the interim, you also were the president of one of Germany's leading engineering and science universities, Technische Universität Darmstadt. That must have given you some experience in how to manage a bureaucracy.
Yeah, it was a very special experience, because I became a professor of Darmstadt University in 1990, and in 1995 they were looking for a new president, and I was not at all thinking about that, but I was in one of the groups of professors, and I said we should not just look for another person, we should have an idea about the profile of the future president. And at the end of this search for a profile, I was suddenly a candidate. And I was elected, and I thought, what to do now? But before I was elected, my campaign was about autonomy of universities. You know, all the German universities were at that time were still very normal public universities, getting the money from the government. And also, when we hired a professor, this had to be justified by the ministry. So even a normal position of a professor. And I said I want to have full autonomy for all of this, also for the money, that I get a bunch of money, and then as a president, I would like to decide where to use it. And we succeeded within several years. It took us several years, from 1995 to 2000 and something, that we worked on a law, which is finally called the TU Darmstadt law. It's really a law for one university, which gave us full autonomy. Unfortunately, my successor then changed some parts of this law. For instance, I asked for not having any civil servant as professor. So this was my successor then said, this is not good for the competition, and so he changed that back. But so it was the first university in Germany getting full autonomy. And then from there, I went to the German Aerospace Center, and from there to ESA.
Mm-hmm. So ESA, the European Space Agency, created in 1975. I think it has 22 member states now. It also has an autonomy issue vis-a-vis not only the governments, the national governments of the member states, but also of the European Union, which I gather is the principal source of funding for ESA. And could you speak just very briefly about the challenge of managing that relationship? I mean, I find ESA fascinating that you can have an organization that includes Norway as a member state, but receives most of its funding from the European Union, has Canada as an associate member. It must be a delicate balancing act, all these different players and funding sources.
So the secret of ESA is this book. That's a convention of ESA from 1975. It's a masterpiece of lawyers. And as you are a lawyer, you should have a look into that. It's really a masterpiece. It really defines all activities of ESA in just a few pages, something like 50 pages. That's all. The first part, this same part, describes everything about ESA. For instance, the organs of ESA. The organs of ESA are the Council of ESA and the Director General. Full stop. That's all. There is nothing more than that. It does not describe the hierarchy in ESA and all of this. It is an international treaty, which many people forget. It was ratified by all the member states. Whenever a new member state enters into ESA, the parliament has to ratify it. Otherwise, you cannot become a member of ESA. So this makes ESA very special. We are an intergovernmental organization. We have some special rules, but we are independent of the European Union. We have, as you correctly said, 22 member states. We have 2 associate member states, Slovenia and Latvia. And we have one very special corporate member state, and this is Canada. So this is part 1, and we should talk about how this is working. Now, the European Union asks us to implement some of their programs. It's not the biggest part of it. It's about 20% of our overall budget comes from the European Union. But the money of the European Union comes also from the member states. Mm-hmm. So the European Union has not money by itself. It does not have taxes or something like that. It gets its money, and they sometimes forget about that. It gets the money from the same member states, more or less, we have. So we have 22 member states, 19 out of which are at the same time member states of the European Union. The European Union has 27 member states, so 19 are directly member states of the European Union. Plus we have Switzerland, Norway, and United Kingdom. So these are the ones which are which are not members of the European Union. But all the other member states of the European Union, the eight, which are not member states of ESA, are at least connected to ESA. Slovenia and Latvia with a special status, and the other 6 just by cooperation agreements. So this is the overall setup.
One of the fascinating things about ESA is that you operate a very large number of missions. I think you have somewhere around 20 operational spacecraft at the moment. So it's not just a bureaucracy. It's not just a political organization. You're actually doing real things in space. And one of them that I'd like to talk about, because I think it's often overlooked, and particularly for my students, I want them to understand this, is the role that ESA plays in climate change science with the Sentinel series of satellites. And I wonder if you could just speak to what Sentinel is and the role that you see ESA fulfilling, and whether that role is becoming more important these days as NASA steps back a bit from climate science.
Yeah, so the Sentinels, so the guardians of our world, so to say, these are very specific parts. So this makes the thing even more complicated, but we have time so that I can go a little bit more in detail. I have to start a little bit different. So we have in ESA, we have 2 main different types of programs. One are the mandatory program, and the other one are the optional programs. So the mandatory program where science is in it, and some other activities like testing, education, etc., all member states have to pay according to their national economy. They have to pay. They cannot say no. They agree all together about an amount, and then each and everyone has to pay a certain percentage according to the economic strengths. And then we have the optional programs. Optional programs means, for instance, Earth observation. We have Earth observation missions, and every 3 years, the Director General has to go to the member states, to the ministers, and say, okay, I have the following idea about Earth observation of the future, or about missions to Mars, or about navigation or telecommunication. And then I give a list of programs with a price tag. And then the member states decide how much they would like to pay for this or that program. Let's assume that one member state says, okay, I pay about 20% of the Earth observation program, which is consisting of several missions, blah, blah, blah. As soon as I say 20% of that program, they are eligible to get something like 20% of the money which flows to industry back into their country. We call that geo-return. And this makes it very interesting for the member states to pay for a certain program. Now you mentioned Sentinel. Sentinel is Copernicus program. The Copernicus program is a program of the European Union together with ESA. And it consists of two parts. One is in the optional program of ESA, and the other part is part of the European Union. So what we are doing is, we are asking, and I did so last year in November, we are asking our member states to subscribe for the ESA Copernicus part. They subscribe for it, and they subscribe the big amount of money. With that, we are building now new Sentinels. Sentinels meaning different missions, for instance, for CO2 measurements, or for radar, or for optical, and so on. Now we are looking in the future, we are looking for CO2 especially. And then we are building these spacecrafts together with industry. And then we hand them over to the European Union, free of charge. But then the European Union says, okay, you built a very nice satellite, we would like to have more of the same. So we call them then the recurrent satellites. And they are paid 100% by the Commission then, but according to what we did in the ESA Copernicus part. So it's rather complicated, but it's a very successful way, and by that we have already several missions we are building, several Sentinels-1, Sentinel-2, etc., and they are all then operated through the European Union, but always in direct cooperation with ESA. So it's really a complicated structure, but it's very successful. That's the most important thing.
And it also makes a major global contribution. So for instance, I have colleagues who are climate scientists who rely heavily on Sentinel imagery. There's a company in Vancouver, Tre Altamira, that uses Sentinel imagery and develops it for various applications for industry and employs dozens of people in Vancouver because Sentinel imagery is so very good and much more accessible than most Earth imagery. So there's a global contribution here as well.
ESA has a free and open policy, data policy, as well as the European Commission has the same. So because I have to say, as I said, some of the part is produced and also flown by ESA. Some is owned, and all of the Sentinels are later on owned by the European Union, and therefore free and open data policy is crucial for them. We have also free and open data policy for an Earth observation program, which is just an ESA program. We call that the Earth Explorers. So for instance, we have now one which is AELOS, which is measuring the wind speed with radar technology. So this is also something which is important for Earth observation, but it's not a Sentinel, but it's just an ESA Explorer mission. Maybe later on the European Union is asking us also to build a Sentinel in that direction. But also for these ESA missions, the free and open data policy is valid, as well for all other programs of ESA. So we believe that all of this data should be accessible for each and everybody around the Earth. However, the member states, that means also, for instance, Canada, they can have a specific access to that which is faster. But this is not a general term. This is more, let's say, a commercial activity in addition. But we have this free and open data policy because I strongly believe, and this is, I'm very happy about that, this is the meaning and the opinion of all member states at ESA and the European Union. Because we need to share this data worldwide in order to fight climate change.
You also as an organization, you make a major contribution to space science also. So at the moment, you have a spacecraft en route to Mercury. It's Bepi Colombo. And one of the interesting things about this, I understand, is that Bepi Colombo, the spacecraft, is going to pass close to Venus a couple of times in the next few months. And of course, we have a potentially very significant scientific discovery from Venus quite recently concerning the existence of unusually high levels of phosphine in the atmosphere. I understand, and maybe you can confirm this, that ESA thinks that one of its instruments on Bepi Colombo might be able to add to the science on this issue.
So Bepi Colombo, the name comes from an Italian scientist, is on the route to go to Mercury. Now, Mercury is the planet which is closest to the sun. So I, as a civil engineer, would say, what the hell? That should be very simple. If you go directly to the sun, you can accelerate, you will be there quickly. Yes, that's right. It would take not so long to go to Mercury, but then you would not stop and you will directly hit the sun. So this is not the plan. So therefore, it makes some what we call swing-bys. Mm-hmm. It goes close to different planets, Mars and Venus, not to Mars, to Venus, and then later on directly to Mars. And by that, decelerates its velocity, not accelerate, mm-hmm. but decelerate. Mm-hmm. And the swing-bys, when it goes close to Venus, will be used to understand more about Venus. Venus is already the next planet closer to the sun, and therefore Venus has a situation which is hotter than the Earth. By the way, Venus has also a greenhouse effect, where this was discovered, and afterwards one was looking to the Earth and found the same effect. So therefore, Venus is already interesting in the past, and Venus has a strong atmosphere. And now, of course, we would also see whether we can get some more information about the atmosphere of Venus. Venus is still a very interesting planet, very close to us. So it's not only Mars. Many people are looking towards Mars, but we believe that also Venus is interesting. This Bepi Colombo mission is also fascinating because if you go so close to the sun, you have very difficult heat situation. So the Mercury has a special situation. Mercury is turning around its own axis and turning around the sun. Mm-hmm. But not like we are also turning around our own axis once a day. And once a year we are turning around the sun, and that means we have summer and winter, and we have day and night. So Mercury is turning very slowly, and that means more or less the most of the time it shows more or less the same path to the sun. So it's like the moon. The moon has not the dark side of the moon, but the far side of the moon and the near side of the moon. And Mercury is doing similar things with the sun, not 100% the same, because it still have a different rotation about its own axis than around the sun. But that means one side of the Mercury is always very hot and one is very cold. And that means for the spacecraft, it's also a challenge to go and turn around the Mercury to see both sides. So therefore, the temperature challenge is a big challenge for Mercury, for Bepi Colombo. But the technology on board is very nice. So therefore, we would like to see also more signs of Venus and then close to Mercury. Already, Bepi Colombo also found something very special on the sun, together with solar orbiter, so-called campfires on the surface of the sun. So we always try to have with our missions very specific information from other planets.
And of course, the solar orbiter is another one of your spacecraft that is doing something similar, but it's focused on studying the sun. Now Bepi Colombo, as I understand it, is a partnership with the Japanese Space Agency. Is that correct?
Most of our missions, if not all, are partnerships with others. So already in ESA, because we have 22 member states, but in most of our missions, we have also strong partnerships with others. In the case of Bepi Colombo, it's 3 spacecraft in one. Mm-hmm. So there is a spacecraft of JAXA, the Japanese. There is a spacecraft of ESA, who are coupled. And then there is a third one, which is the Iron Thruster, the spacecraft which is moving the spacecraft overall. So this is the engine of the spacecraft. So we have 3 spacecraft in one. Yes, it's a very strong partnership. And when we are close enough to Mercury, they will separate from each other.
I often describe ESA as a partnership of partnerships. And it's fascinating to me as someone who studies international relations and international law, how you created this very successful network to get things done. And one of the most interesting partnerships to me is your partnership with Russia, with Roscosmos, the Russian space agency, which I understand started on the International Space Station, and Russia is, of course, a full partner on the ISS. And that partnership has grown into other examples of cooperation. And you know I'm going to ask you about this. I want to ask you about the Mars missions, which are progressing in a partnership between ESA and Russia, and like many Mars missions, have encountered some problems and thus learned a lot from those problems. I'm less interested in the mission itself, and more interested in how you see that partnership with Russia in terms of the history so far and the current and future state of that partnership.
So the mission is called ExoMars because we are trying to find out whether there was or there is life on Mars. There is some probability because Mars had a better history than today, a better atmosphere, a better temperature. So there is some probability that there was something like life or there is something like life. So therefore, ExoMars is looking to that. As for that, we need 2 missions. One is a trace gas orbiter, which is right now close to Mars, flying around Mars in an orbit, measuring the gases, the atmosphere of Mars. And it will be a relay station for the next mission, which is a rover, which should move on the surface of Mars and then drill into the surface of Mars about 2 meters deep to look for something like life. Because on the surface of Mars, because of the radiation, etc., there is nothing what could be called life, but maybe inside the surface. So these are the 2 main missions. So when we traveled to Mars in 2016, we thought it's a good idea to test also a landing, because landing on Mars is very, very difficult. Many countries failed. We as well with Beagle, but many failed. So we said, okay, let's try to land. And the mission was called Schiaparelli, an Italian park. So when you want to land on Mars, you need to have a heat shield first because you have an atmosphere. The heat shield worked perfectly. Then you can open a parachute because you have an atmosphere. The parachute worked perfectly. You have to separate the heat shield because of weight. That worked perfectly. Finally, you can separate the parachute. This worked perfectly. You can start the engines for the final deceleration. The engines were started, but after 3 seconds, the computer switched off the engine, and we had a relatively hard landing, I should call it, on the surface of Mars, so it was an impact. We learned everything what we wanted to learn, but of course it was seen as a failure. Now I make a comparison with Elon Musk and his trial to land his first stage on a small barge, on a small ship. He failed 3 times. In his 3rd time, when he tried to land, the rocket exploded, and Elon tweeted, "Rapid Unscheduled Disassembly, RUD. Ship is fine, minor repairs, exciting day." So he was talking about the ship instead of the rocket. So if I would have said the same after Schiaparelli impact, RUD, Rapid Unscheduled Disassembly, Mars is fine, no repairs, exciting day, I would be fired. So this is the difference between the American and the European culture. So now we are looking to life on Mars, and the cooperation with Roscosmos is very good. So no problem. It's not the only mission where we are cooperating, but you mentioned correctly ISS. In this trial, so the 2016 mission, it was already a Russian launcher which brought us to Mars, and it will be also the next mission, which will be launched hopefully in 2022. It is the rover, again launched by the Russians, and also the descent module, which goes down to the surface of Mars, will be a Russian one, and then we have the European launcher, the European rover over there. So we have a strong relation, and it's the beauty of ESA that we are not directly linked to all these sanctions, etc., which happens. We can work with our international, our intergovernmental status. We can work with East and West at the same time.
And do the member state governments see this relationship between ESA and Roscosmos as diplomatically important, as a way of keeping communication and cooperation ongoing during these difficult times?
I always argue like that. I don't know whether the government see it like that, but we are really preaching earthly crisis. That's for sure. We do it. In 2014, I was still the head of the German Aerospace Center. There was a European astronaut with a German passport to be flown to the International Space Station, Alexander Gerst, and I was invited to come to the launch. Mm-hmm. And I was very afraid. In 2014, it was just after the Crimea conflict started between Ukraine and Russia, and there were a lot of sanctions, etc., etc. And I traveled to Baikonur in Kazakhstan for the launch, and I was really afraid. What should I see? What is possible? And then I saw the three astronauts, a Russian cosmonaut, an American astronaut, and a European astronaut sitting together and saying, okay, now we are flying to the International Space Station without any visa problems, etc., etc. So I thought, okay, humanity is not at the end of the day, so we still can do something if we are bridging earthly crisis, and space can do that.
So what about China? I know you have some cooperation with the Chinese Space Agency. Could you speak to the relationship with China for a minute or two?
We have also with China, we have some relations. So to be very clear, so NASA is our premium partner with regard to big projects. Canada is a big and very important partner for us. But we have also relations with Russia, as I mentioned, and also with China. So for instance, with China, we are now preparing a mission which should investigate the magnetosphere effect of the sun on our magnetosphere, because solar flares is one of the big dangers. I mean, you in Canada, you know what happened in 1989 with a solar flare hitting one of your power stations and burning some of the electric wiring over there. So therefore, solar flare is something we should take into consideration and pay attention to. So therefore, together with China, we are preparing this mission. We know, of course, and we are not naive. We take care also of intellectual property rights and human rights. But international collaboration has to look to it, but also to work beyond these issues. This is a difficult path to go, and I can tell you why it is so difficult. So, for instance, in Europe, capital punishment is a no-go. Mm-hmm. But we are working together with China. Oh, is that possible? Capital punishment is a no-go, but we are working together with Japan. Is it a no-go? Capital punishment is a no-go, but we are working together with the United States of America. So you see, what I wanted to say is, yes, I have my personal ethics, I have my personal opinion, and I believe the best is to cooperate also with those who have a different opinion. By that, maybe I can convince the one or the other also about my position. It's better than to isolate. Isolation does not help.
And you can also address important space safety issues like solar storms,
Yes.
and do good while cooperating with a country that has a system that you may disagree with.
Or climate change. It's
Exactly.
the same, climate change is not a national issue. It's a global issue. And therefore, to work together, and I always said, let's work together globally and exchange data on CO2, etc. Only then we can do something against it. Because raising awareness is very important for doing something to do, have some mitigation effects for climate change. First of all, you have to discover it. Number 2, you have to monitor it. Number 3, you have to raise awareness. Number 4, mitigation. All of this goes much better in international collaboration, as we saw, by the way, also with the COVID crisis. That's exactly the same. Discover it, monitor it, raise awareness, and mitigate.
Which is the perfect opening to discuss planetary defense and the threat from asteroids and comets. Very low statistical risk, but very high consequence if it were ever to happen. And I know that ESA is partnering very closely with NASA in an upcoming mission, the DART mission. And I think there's been a recent development from your side with that regard. Could you speak briefly to where ESA is in terms of planetary defense?
You see, risk is, from an engineering point of view, it's a probability or likelihood of something multiplied with the amount of damage. Now, if you look to an asteroid impact, as you correctly said, the probability is very low, but the consequences might be enormous. So, for instance, the dinosaurs died out because of an asteroid impact, most probably. So, therefore, I have the problem when I wanted to get money from the ministers. They asked me, will it happen during my term? And this, of course, I cannot guarantee. So, therefore, it is important to convince people, even if it's without their perimeter of thinking. So there is some probability, and sometimes we have really surprises. And so the asteroids around the sun, they are very well known, and we know what happens. But we had, I think it's 2 years ago, when Oumuamua suddenly, a guest from outside our solar system, came very close to the Earth. Close means it is close if you are, let's say, in a distance of 1 million kilometers. I still call it close. And this was even closer. So therefore, we have to do something. And Bruce Willis did it once in Armageddon. He will not do it again. So we have to be prepared. And again, similar to what I said before, you have to discover it. You have to monitor it. You have to raise awareness, and only then you can mitigate. And therefore, together with NASA, we are now planning to go to a small moon of an asteroid. So asteroids, there is an asteroid called Didymos, and it has a smaller one, which is Didymoon, which is orbiting this small asteroid, because we have to start with a small one, and we want to play billiard in space. So the Americans are better in hitting and shooting than we are. So they will hit this small moon, and we will observe it later on, because billiard is simple compared to that. Billiard, you have a spherical ball. You know where the center of gravity is. You know the surface. You know where you have to hit to get a certain place. And all of this is different with an asteroid. So it's not round. The distribution of mass is not equal. So therefore, we have to learn a lot how to play billiard in space. And only playing billiard in space is the only solution. We cannot make the way of Armageddon, just have an explosion with an atomic bomb. This is much too dangerous because you get all the different debris on the surface of the Earth. So therefore, we have to play billiard far away from the Earth, hit it in the right direction so that it's not hitting the Earth. And therefore, this is a cooperation with NASA. You are totally right. And again, it's a cooperation of many member states and states beyond.
You also have a major cooperation with NASA with regards to the Lunar Gateway, which Canada is also a partner in. We're going to be building a Canada arm for the Lunar Gateway. But associated with that, the United States is also looking to actual landings on the moon. And I understand there is seeking to get agreement from partner states on the issue of resource extraction, and more specifically, whether or not there's a right to extract revenue, to engage in commercial activity with regards to space resources. Now, I know this is an open debate. I know that also the United States has made a bid. It has put forward a position. I don't think ESA has taken, or the member states have taken a position, although one of your member states, Luxembourg, certainly has. Can you tell us your perspective on this issue? Because it's obviously front and center for space policy and space law people today.
First of all, congratulations to Canada and the Canada space people that you put the Canada on your money, on your banknote. Mm-hmm. This is really something which is very important for people see always that there is a space activity. So this was really, I really congratulate, and I'm a little bit jealous about it. But anyhow, it's very good. So number two, it's also good that Canada already agreed to invest in the gateway for the next many years. So this is also very, very good. So from the European side, we have the following. We have, first of all, when the Americans go to the moon next time with SLS, the new launch system, then there is a critical part, which is a service module coming from Europe. So this is, we are very happy that we can provide this one. And we are also providing elements for the gateway. So everything of this is, at least from the European side, it's fine. Now and by the way, what is important for me when the Americans and others go to the moon, the American vice president is talking about going back to the moon. And I'm always saying this is not correct. That would be the same as 50 years ago in race in space. And therefore, I'm always saying, let's go forward to the moon this time. That means going together to the moon, forward to the moon. And I believe we have an opportunity for that. And you're right, the question of resources is a very touchy subject. For instance, China believes to get helium-3 from the surface of the moon. So in ESA, we have a in-situ resource utilization program. So we are ready to use it, but so far we don't believe that in the near future it makes sense to bring the resources back to the Earth. Mm-hmm. And that's, by the way, also aligned with Luxembourg. But to use it, that's a very important part. So first of all, when we go to the moon next time together, forward to the moon, the astronauts needs some shelters, because the Apollo astronauts were really lucky that there was no solar flare when they were on the surface of the moon or on their travel. So therefore, next time when astronauts stay for a longer time on the moon, they need some structures, and these structures should be built by using material of the moon, so in situ resource utilization. We can also think about, for instance, we have right now 4,500 satellites flying around the Earth, and only 1,500 are in operation. So 3,000 are flying there, or falling there, whatever you call it, with a lot of very expensive material. So one can also do recycling in space, and this is also in situ resource utilization. So therefore, we are supporting all of this, and we have a program for that. What we don't have is to bring material from the moon or from other places back to the Earth, because we still believe that launching capacities and launching is much too expensive for that. But maybe that comes, but not close, and we should not say that in 100 years, half moon means really that only half of the moon is there. So it should be still that we have the full moon because the Earth needs it. But I don't believe that this will be very soon happening. And also the asteroid mining and all of this. It's a nice vision. And Luxembourg was always very famous in visionary projects like the telecommunication. So therefore we are supporting that, but we have no ESA direct program to bring resources back from any celestial body.
So you just mentioned the issue of debris in Earth orbit. And a few minutes ago, you mentioned Elon Musk and SpaceX. Now, SpaceX has a license from the United States Federal Communications Commission to place nearly 12,000 communication satellites in low Earth orbit. They as we speak, they had another successful launch just a couple of hours ago. They have almost 800 of these satellites already in orbit. China, I've just learned, has filed an application with the International Telecommunications Union for its own mega constellation of nearly 12,000 satellites. I know ESA is very active on trying to address the issue of space debris, but certainly these private actors are they're exacerbating the problem, are they not? Rather than helping to find a solution.
I'm very happy that I could convince the ESA member states in last year to really pay for a space debris removal mission. So we are the very first entity having such a mission really paid. And so we believe that this is very important. I mentioned already the 4,500 satellites now. With Elon Musk, we will see a rapid increase of that. There are some other mega constellations in planning. And therefore, we need to do something. We cannot accept that because it's dangerous. For other satellites, space is meanwhile an infrastructure for earthly applications, and we cannot dare that there will be accidents. And there were accidents, for instance, between Cosmos and Iridium. We had an accident last year. It was a nearby accident between Aeolus, an ESA satellite, and one of the satellites of Elon Musk constellation Starlink. So therefore, we have to do something. We need, number one, debris avoidance, so that there will not be more debris produced. Number two, we need debris removal. And so the first one, debris avoidance, that can be done directly during the launch period, so that there is not an upper stage flying around, etc. Then we are planning, and we got the money for that as well, to use satellite collision avoidance systems like we have for planes, but it's a little bit more complicated in space, but this is using artificial intelligence. And we have this mission to reduce space debris. For my vision is that in future, whoever launches a satellite has to secure one of the following three possibilities. One is sufficient. Either the system has on board an automatic independent deorbit mechanism with a small rocket deorbiting, but independent, not saying, yeah, I have some spare fuel at the end of lifetime, I will use it and then I will deorbit. No, it should be independent in case the satellite is not working any longer. And we have enough satellites which are not working. Or number two, the company or the institution which is launching a satellite has a contract with a company which secures the deorbiting, guarantees the deorbiting by robot action or whatever. Or number three, the company or the institution launching a satellite gives a deposit to an agency, and if it does not bring back the satellite by deorbit it, then the deposit is used to ask a company to bring it down. So I think this is a very simple restriction, and it would avoid future space debris. So I believe and I hope that we can, at a certain point in time, manage to have this. I don't know whether we need for that new rules and regulations all the time. It's also something like space ethics, which I think can be done.
It certainly is peculiar, though, that the only international organization involved with these constellations is restricted to the allocation of radio spectrum, right? And the licensing bodies are actually national regulators who are telecommunications regulators, which begs the question: I mean, who's actually thinking about debris? Who's thinking about the effect of these spacecraft, these satellites, eventually returning to the Earth's surface, at least in part? There are more issues involved than the current governance mechanisms can deal with. And the treaties that we have, the space treaties, are old treaties. They date to the 1960s and the 1970s, and some people think that we can do this with guidelines, with non-binding mechanisms and cooperation and goodwill. And you're at the center of all this. Do you think that non-binding coordination can manage not just the debris problem, but the other new issues we face in space?
You see, I don't need a law that prevents me from killing another person.
Mm-hmm.
I don't need a law for that. Not at all. I don't need a law which prevents me from stealing something from other people. I don't need. But this is maybe a naive thinking. And I always hear that my ideas, which I mentioned with these three options, these are nice ideas, but it is disturbing the competition. Yes, I can understand. But in many other fields, we found out that finally the green solution was winning. So I believe we have to fight for it. And maybe we need some regulation, some rules, but I'm not so happy with rules and regulation. Also, I'm a German, and normally Germany always is full of regulation. But I still believe in good faith and in positive people.
One of the factors in Earth orbit that people don't often discuss when talking about national space agencies and commercial actors is the presence of an awful lot of military satellites. And the U.S. military has been quite emphatic that they're very concerned about space debris, that they see this as a massive threat to their own operations. And doesn't that give people like you who want the management of Earth orbit to be done in a safe way, doesn't that offer you some really powerful allies in terms of national militaries?
Yeah, that's a question whether we would like to have those allies, because the convention again is saying exclusive peaceful purpose. So it's very clear. Sure. So we cannot and we should not, and I don't want to have any military actions in space. It's Star Wars is not my field. So I know that many actors are afraid of space debris. From one of these mega constellations, the CEO of that company told me, can you not help us that our orbit is clean of all any other satellite? He wants just his orbit. And I said, what do you do if your orbit, if a spacecraft, a satellite stepwise goes down because of deceleration by air? Oh yeah, that's at the end of the spacecraft only. I don't care about that. But this is, you see, he was just thinking about his own orbit. So I believe, yes, we should have much more people supporting us in fighting really the space debris. And I will try. You see, my term as Director General ends in the middle of next year, and the next meeting with ministers is in 2022. But I will still propose that in the next ministerial, we also have a mission prepared which goes for the tiny parts. You know the movie Gravity, which has some mistakes in the movie, but that's not the point. But it's a fact that these tiny particles of even 1 centimeter diameter only, we have about something like 750,000 right now, that they are dangerous. With a velocity of 28,000 kilometers per hour, they are faster than any bullet of a gun. And therefore it's dangerous, and one of these particles hit also one of our satellites. one of the Sentinel satellites and destroyed the solar panel. So it's really a danger. And with that, knowing about that, we should have also missions not only grabbing the big ones, the big satellites, but also the tiny parts. And therefore, if we can find some allies, we are happy, but not for military purpose.
Yes, and the civilian-military split is one that fascinates me, because when it comes to a safe operational space to Earth orbit, the interests align perfectly, but there's an extremely strong policy reason for having the separation.
I can give you another example for that. When I was talking about space situational awareness, also the tracking of satellites, they believe, the military people believe, they should not disclose their orbit. In 1957, I mentioned that one with Sputnik, immediately one could follow the way of that satellite, even with the technology in 1957. And this was, by the way, also the birth of satellite navigation, the other way around, from the ground to the satellite instead of from the satellite down. So therefore, there is no secret in space. And therefore, I believe that all orbits of all missions should be published in order to avoid any future accidents. Anyhow, you can find it out, but I don't understand why the orbits of satellites should be secret. I can understand that military people don't want to publish what they can do with their satellites. But to publish the orbit directly is nothing. It's not a special information.
Now you mentioned that you will be stepping down as Director General of ESA next year, but you're still a young and energetic man. I'm not asking about next steps. The question I want to ask is not about next steps, but you must be thinking about the long-term development of space, and you must have your own opinions as to where space cooperation and science should go. Are you at the stage where you can begin to express some of those own personal views as to the future of space?
I'm a free man in a free world, so I can do that all the time, and I did it all the time. So I'm old, I'm 66 already, so no problem for that. I'm very grateful for what I could do the last, let's say, 60 years or so. I'm not so happy that my term ends next year. And my vision is, of course, that space will be really a commodity which still has fascinating aspects, because for the commodity, it's commercialization, etc. This is good. Mm-hmm. I see that Earth observation will be commercialized. I see that telecommunication is already commercialized. I can see that navigation mainly can be commercialized. But there are some parts which should never become a commodity. This is exploration, science, and safety and security, especially exploration and science. These are the missions which fascinate people. Fascination is a very positive movement in your head, of the brain. And we need positive movements in our head, especially because on Earth we have enough problems like COVID-19 and other diseases and problems. So through fascination coming from space exploration and space science, we can fascinate people. Fascination is a basis for inspiration. Inspiration for me is to think about. Fascination is just to say, wow. But inspiration is to think a step further from this, what one sees. And then the next step from inspiration is motivation. To say, okay, I can also do something different for the future, for this world or whatever. This was, by the way, how I explain always that I became a civil engineer, because I was seeing these space guys, this is just excellent. I'm not a space guy, so what can I do? Where can I bring a difference to this world? And I decided maybe as a civil engineer. So therefore, I believe that space has a societal impact much larger than just only climate change. It's big, but it's bigger than that. It really can make a difference for individuals in our society to have a positive understanding and motivation for the future.
I make my students go out at night and see the International Space Station at least once during the semester in which I'm teaching them. It's an actual requirement. I put a question on the final exam that they can only answer correctly if they've done this, if they've seen the International Space Station. And part of the reason I do this is to expand their minds to understand that human beings already live in space. We have a habitation that has had human beings on it continuously for 2 decades now. And then I encourage them to also begin to do a bit of astronomy and to focus in particular on Venus, on Mercury, on Mars, because these are the places that we are going, right? We're there already with robotic spacecraft. And to begin to encourage them to think of themselves as inhabitants of a solar system, which in turn is within this galaxy. There's
only one danger in that thinking.
Yeah.
And this is if people start to think, okay, if the Earth is getting worse, we can move and live on Venus or Mars, because that would be a good excuse not to take care of the Earth. So this is the only aspect which we should avoid. So the best place in our solar system is for sure the Earth. And this is, I would love to go to Mars, yes, but I would not love to stay in a can for the rest of my life, even it's short. I would not do that. So therefore, to go there, to make research, to make holidays or whatever, that's fine. But finally, the Earth is the best planet, best place to be so far. Maybe there is something out there.
It is. If there is something out there, it is a very great distance away. And so the flip side of this, of course, is the pale blue dot, the realization that Earth is truly unique within this solar system, and therefore the only place, the only good home that we have. And this is why I started this conversation with Sentinel, right? Because space is partly about going out, but it's also about understanding where we are and helping us to do a better job of managing this planet.
Yes, and this is a point when astronauts are coming back from space. They bring back more than just images like Sentinel. They bring also back emotions. Mm-hmm. And if they tell us that this thin atmosphere, that this is really something which is very special. A thin atmosphere. I always compared if you would shrink the Earth to the size of a football, then the thickness of the atmosphere where we can still breathe is about the thickness of one single hair, the thickness of a hair. So it's really thin. So we better take care of that, and therefore I always like when astronauts are telling us that they see this fragile Earth, and what they say is they don't see borders, they don't see national borders on Earth. So there is a borderless Earth. This is very nice. You can see the border between North and South Korea, but this is a very special case. But normally you don't see any border. This is so astronauts are with their emotions, for me, very important ambassadors beyond sentinels, beyond guardians. They are ambassadors.
Well, this has been a fascinating conversation, Dr. Wörner. I'd like to express my thanks both to you and also to the European Space Agency. You've done a lot of good for humanity, not just for space science, but for climate science and for prompting people to have a more optimistic, cooperative vision of humanity and our place in the universe. This is all really important as contributions. So thank you to you and to all of your staff. You have an open invitation to visit the University of British Columbia when that becomes possible again. And I would love to put you in a classroom with 130 of my students so that they can ask the questions next time.
And I would love to do so, because this is really what comes to my heart, to have interactions with students. I'm still teaching at the university because I love it.
Well, thank you very much. Vielen Dank und bis nächstes Mal.